We've observed constant velocity, and we've all seen and heard the words speed and velocity. Today, let's talk about the difference between the two. In order to understand the similarities and differences between speed and velocity, we need to understand two different types of values that we see in physics: vector values and scalar values. Scalars is any quantity that has just a magnitude, no direction. So this is just a value, just a number. Speed is an example of a scalar. If I look at a speed limit sign outside, it says 25 miles per hour. That's 25 miles per hour whether you're going east, west, north, south, forwards, backwards, left, right. The direction doesn't matter because we're just looking at the scalar value. A vector has both a quantity and direction. So it has a magnitude, a number, and direction. Velocity is like speed in that it tells you how fast you're going, but velocity also tells you a direction. So a car no longer is just going 25 miles per hour, he's going 25 miles per hour east, 25 miles per hour forwards, 25 miles per hour backwards. The direction and magnitude are connected together in a vector. Distance and displacement are another set of great examples of vectors and scalars. Distance is a scalar. It's an amount that you've traveled. You could tell someone to go 3 blocks, whereas displacement is a vector. You would tell someone to go 3 blocks forward, 3 blocks east. Distance and displacement are both very important to understanding the difference between speed and velocity. You can think of distance as the measure of the path taken. If I walk 4 blocks, I can walk 4 blocks in any directions. If I walk 2 blocks forward, 2 blocks backward, I just walked a total of 4 blocks. It's a scalar quantity. Direction doesn't matter, it only has magnitude. So we have our start, we have our stop. Every twist, every turn, every back, every forward is accounted for. Every single step. Something like a Fitbit would be an example of your distance. A related cousin to distance is displacement. Displacement is the measure of distance between your start and stop. We're looking at how far you are from where you started. It's a vector quantity, so it's not just 3 blocks, it's 3 blocks forward, 3 blocks backwards, 3 blocks south. It has magnitude and direction. So we look at start and stop, whereas distance shows the entire path, every step, every turn, every twist. Displacement just shows us from start to stop. It's a straight line distance. This would be closer to a GPS or a flight map for an airplane. Speed is related to distance. It's how fast an object is moving. It's distance over time. So again, distance being a scalar measurement. It does not have direction. Speed does not have direction either. They are both scalar. That's why speed limit signs do not say 45 miles per hour forward, 45 miles per hour east. They just give you the speed, how much distance you can cover over time. To find your average speed, you would need to take your total distance divided by time. So for example, if you were out on a walk in the city and you walked for 5 blocks in one direction, you took a right turn, you walked 3 more blocks, you took another turn, etc., etc. You would add every distance together and divide by the total amount of time that it took you to travel that total distance. Speed and velocity are similar, but velocity tells us a little bit more. Velocity is how fast an object is moving, which is the definition of speed, but it's also which direction it's headed. Speed would be 5 meters per second, velocity would tell us 5 meters per second forward or 5 meters per second backwards. It's displacement over time. Displacement has a direction, so we have a distance with direction divided by time. That means that displacement and velocity are both vectors. We're taking a vector and dividing it by time, so we get a vector quantity. This is why displacement and velocity both tell us the direction. A positive velocity means you're moving forward, or in some cases up. A negative velocity means you're moving backwards, or in some cases down. This is when we're referring to just working in one dimension. Average velocity is calculated by taking total displacement divided by time. This is where understanding the difference between distance and displacement is very important. If I walk 5 blocks forward and 5 blocks back, I've walked a distance of 10 blocks, but I ended up at the exact same place I started. My displacement is 0. Remember, displacement is the distance or the difference between your beginning position and your final position. This is why speed and velocity aren't always the same. Especially if you change directions, you'll see a velocity that differs from your speed. Let's visualize the difference between our scalar and vector values. Jim Shu runs the following route in 2 hours. Find his distance and displacement, his speed, and his velocity. So if he were to run 8 miles, then 6 miles, it does not matter which direction he ran. This is going to be his distance. So even if he changes direction, we just add them up. 8 plus 6 is 14 miles. His speed would be the distance divided by time. He ran 14 miles in 2 hours. That's 7 miles per hour. His displacement and velocity are based on the change in his position from his starting position to his ending position. So if we go from start to finish, we would need to look into a little trigonometry. That's a 3, 4, 5 triangle, so that means he went 10 miles northeast. Well, let's look. He went 8 miles east, 6 miles north. So he went 10 miles from start to finish, straight line, 10 miles in a northeast direction. Average velocity is calculated by taking displacement and dividing it by time. So if he went 10 miles in 2 hours, that means he had a velocity of 5 miles per hour northeast. Again, displacement and velocity always have a direction: north, south, east, west, forward, backward, up, down. Whereas distance and speed don't tell us as much information. This is one of the reasons why in physics class we start seeing more displacement and velocity as being important compared to distance and speed. Let's analyze these concepts relative to a position versus time graph, similar to the constant velocity buggy lab. Let's look at our scalar values first: distance and speed. Well, distance, again, that's how much he walks in one direction, another direction, etc. So we start out at 2 meters and we go up to 4 meters. That's 2 meters in one direction. The direction doesn't matter. Then we start all the way up at 4 meters and go all the way backwards to 0 meters. The backwards aspect doesn't matter because we're looking at distance. So we go a total of 4 more meters. So we went 2 plus 4 gives us a distance of 6 meters. So really what this object or person or car, whatever this is, goes 2 meters forward, goes backwards 4 more meters, passing where it started. Started at 2 meters. So that means over time, since this took place over 4 seconds, to find our speed, we would do 6 divided by 4, which would give us a velocity of 1.5 meters per second. The direction is not implied, though, if we're looking at average speed. We don't know a direction here because it's a scalar value. For our vector values, we're looking at the change in position. So if we're doing average velocity, we need to look at the change. We look at the displacement. So he started originally at 2 meters and ended up behind themselves, so down 2 meters. So displacement was -2 meters. Remember, that negative tells us backwards. Positive would tell us forwards. So if we had a displacement of going backwards 2 meters, we have a velocity that's going to be -2 over 4 seconds. So that's -0.5 or -1/2 meters per second backwards. The negative on our velocity signifies that it's moving backwards, but it's best practice when we're describing motion in physics to describe the type of motion. So in this case, meters per second, we're describing velocity, and to describe the direction of the motion, in this case, backwards.